Hi there. In this video, we will examine ratios and proportions. Notice some terminology on the left. A proportion is a statement of equality of ratios. So, in this example, we have a proportion with 1/5 equal to 5/25. I'm going to label the terms A, B, C, and D so we can answer some questions. The means are the second and third term of the proportion, so 5 and 5. The extremes are the first and fourth terms of the proportion, so 1 and 25. The product of the means is 5 times 5, so 25. The product of the extremes is 1 times 25, so 25. Notice this fits the cross product property, which states if the product of the means is equal to the product of the extremes, then it is a proportion. In this example, we have the proportion of 1/3 over 1/2 is equal to 4/6. So the means are 1/2 and 4, the second and third term, and the extremes are 1/3 and 6, the first and fourth term. The product of the means is 1/2 times 4, which equals 2, and the product of the extremes is 1/3 times 6, which is also 2. Again, notice this fits the cross product property for proportions. More examples. Here we are solving for the variable that makes the proportion true. So we use the cross product idea to solve each proportion. So here, using the cross product, we end up with 9y equals to 7 times 4, which is 28. And y equals 28 over 9. Next example, we do the same process. Use the cross product and divide to solve for the variable y in this case. And we end up with y equals 35 over 8. Third example, same process. Find the cross product and divide to solve for x. And we get x equals 135 over 13. In this example, we have two rectangles that are similar. Note, this symbol, tilde, is the notation for similar. Since these figures are similar, that means the lengths of their corresponding sides are proportionate to each other. So b over 2 is proportionate to 25 over 5. Now we solve for b using the cross product, getting 5b is equal to 25 times 2. Then, dividing both sides by 5, we get b equals 10. And done. Now let's look at another example with similar polygons. Polygons are similar if the ratio of their lengths are proportional. So if 24 over 30 is proportional to 60 over 75, then the two polygons are similar. So we use the cross product to see if that is equal, and it is. So the polygons are similar.
Playing on your radio, coming through your stereo, and everybody's getting down. You can see the let it go, running like a video. You're haunted by the weight of sound in your eyes. You both.
So we can say ABCD is similar to JKLH, and their similarity ratio can be found either with 30 over 75 or 24 over 60 to get 2 over 5. Some music while I write some of this down. In this example, we have two triangles where we know information about their angles. So let's find the third angle of one of the triangles and see if the triangles have the same angle measure. If they do, that means they are similar triangles. So let's call the unknown angle x, then use the triangle sum to find out what x is. Solving, we end up with 32 degrees for the missing angle in the second triangle. And then we see that all the angles of both triangles are congruent. So that means that these triangles are similar. So we can write that triangle LMN is similar to triangle PQR and has a similarity ratio of 42/70. That simplifies to 3/5.
Playing on your radio, coming through your stereo, and everybody's getting down. You can see the let it go, running like a video. You're haunted by the weight of the sound in your eyes. You
And done. Next example. Here we know triangle MNP is similar to triangle XYZ. So looking at the two triangles, we know PN corresponds to ZY and MP corresponds to XZ. So we set their ratios equal to each other since they are proportional. Then we use the cross product. Now we distribute to get rid of parentheses and simplify. Get the equation in standard form, where one side has all the terms and the other side has 0. Also notice all the terms have a factor of 2 in common, so we can divide that out. Now we have a quadratic equation, which we can solve by factoring by grouping. So we look for factors of the constant and leading coefficient, -4 times 3, being equal to -12. That add up to 1, which is the coefficient of the middle term. Looks like 4 and -3 work, so we then split the middle terms as those factors 4y plus -3y. Factoring a 3y from the first group, then a 4 from the second group, we can then factor y minus 1 out. Then we solve y minus 1 equals 0, and 3y plus 4 equals 0. We get y equals 1, and y equals -4/3. Since -4/3 produces a negative result, the only solution is y equals 1. Now let's look at a couple of examples that involve triangle similarity. Some triangle similarity postulates are on the left side. Using the sum of angles of a triangle is 180 degrees, we can figure out the angles of these triangles. And now we can see that both triangles are similar by the angle-angle postulate. In this example, we have two triangles that have their sides given. The side-side-side postulate for similar triangles says if the ratios of their corresponding sides are proportional, then the triangles are similar. So let's check the ratios of their corresponding sides. We will do LM over MN and set it equal to PQ over QR. So 70 over 40 equal to 28 over 16. Then use the cross product to see if they are proportional. Also, we will set LN over MN equal to PR over QR, so 55 over 40 equal to 22 over 16. Then we will use a cross product to see if they are proportional. Music while I write.
Playing on your radio, coming through your stereo, and everybody's getting down. You can see the let it go, running like a video. You're haunted by the weight of sound. In your eyes, you both no matter where you want to see. All up in the video, playing like when they get the big game. Oh, what's the saying? What the more you know? People sing the same song. Listen to the song. People sing, but nothing don't sing the way the song is singing.
So we have verified that the ratios of the sides of the two triangles are proportional. So the triangles are similar by the SSS postulate for similarity. We say triangle MNL is similar to triangle QRP. Another example. Here we have two triangles, and notice that one is inside the other triangle, and we are given one angle is congruent. We actually know that angle GCE is also congruent to angle DCF since that angle is part of both triangles. So the triangles are congruent by the AA postulate for similar triangles. We say triangle GCE is similar to triangle DCF. So we get CG over GE equal to DC over DF. Notice segment DC is x plus 2 plus 5. Then we use the cross product.
Playing on your radio, coming through your stereo, and everybody's getting down. You can see the let it go, running like a video. You're haunted by the weight of sound in your eyes. You
Distribute to get rid of the parentheses. Then we simplify and isolate x. And we get x equals 3. In this example, we want to find the value of x given that triangle FCE is similar to triangle FDE. So this means FC over CE is proportional to FD over DE. So this means we can set x over 3 equal to 12 over 4. Then we just use a cross product and solve for x. We end up with x equals 9. In this example, we have a diagram and we want the value of a. We notice that there are two parallel segments dividing the triangles, so we can mark that corresponding angles are congruent. So we can write that triangle GFE is similar to triangle GDC by the angle postulate for similar triangles. Now we can set corresponding ratios equal to each other. We set GF over GE equal to GD over GC. For segment GD and segment GC, we do have to add the pieces of the segments together. So we have 2 over 2a minus 5 equals 2 plus 3a plus 3 over 2a minus 5 plus 6. Then we use a cross product and solve. Distribute to clear parentheses.
Since they're full of souped up automatic, just can't quit. Let the bass hit right on time. Running hard to the end, to in a panic automatic smile, knowing you'll be mine. Full of souped up automatic, can't quit. Let the bass hit right on time. Running hard to the end, to in a panic automatic.
Move all the terms to one side and get 0 on the other. Divide both sides by 3 since it's a common factor and it makes it easier. Then we can factor by grouping. Looking for factors of the constant and leading coefficient, negative 9 times 2 equals negative 18 in this case. We want factors of negative 18 that add up to the middle term's coefficient, negative 3a in this case. So negative 6 and 3 work here. So split the middle terms as those factors, negative 6a and 3a, then factor by grouping. Factor a 2a from the first group, then a 3 from the second group, then factor the a minus 3 out and solve each of the factors for a. We end up with a equals negative 3 and a equals negative 3 halves. A equals negative 3 halves will not work since it gives a negative result. So x equals 3 is the only solution here.